Dear students, today we are going to study Bayes' theorem. This is the part of module 4 of Statistical Methods of MA Economics Part 2. I am Dr. Rashmi Akhori, Department of Economics, College of Commerce, Arts and Science, Patna. Learning objectives of this topic is you will know what is Bayes' theorem and how to work through calculation. You will know that it provides principled way of calculating conditional probability. Bayes' theorem is a pillar of both probability and statistics, and it is central to the rest of probability. What is the essence of this theorem? The essence of Bayes' theorem is to recognize that we are dealing with sequential events whereby new information is obtained for a subsequent event, and that new information is used to revise the probability of the initial event. In this context, the terms prior probability and posterior probability are commonly used. The R.T. Bayes was an English minister and mathematician. Although none of his work was published during his lifetime, later publications included the following theorem, a rule that he developed for determining probabilities of events by incorporating information about subsequent events. For two events A and B, Bayes' theorem, also called Bayes' rule, Bayes' formula, says probability B oblique A equals to probability A by B multiplied by probability B divided by probability A. Comments. Bayes' rule tells us how to invert conditional probabilities. That is to find probability B oblique A from probability A oblique B. In practice, probability of A is often computed using the law of total probability. Basically, what is the proof of Bayes' rule? The key point is that A intersection B is symmetric in A and B. So the multiplication rule says probability B oblique A multiplied by probability A equals to probability A intersection B. This equals to probability A by B multiplied by probability B. Now divide through by probability A to get Bayes' rule. A common mistake is to confuse probability A by B and probability B by A. They can be very different, and this is illustrated in the next example. Toss a coin 5 times. Let H1 is equal to first toss is heads, and let H1 equals to all 5 tosses are heads. Then probability H1 oblique HA is equal to 1, but probability HA oblique H1 is 1 by 16. For practice, let's use Bayes' theorem to compute probability H1 by HA using probability HA oblique H1. The terms are probability HA oblique H1 is equal to 1 by 16, probability H1 is equal to 1 by 2, and probability HA is equal to 1 by 32. So, probability H1 by HA is equal to probability HA by H1 into probability H1 divided by probability HA. This comes to 1, that is 1 by 16 into 1 by 2 divided by 1 by 32, and this comes to 1. How will you define then Bayes' theorem? If H1, H2, H3 and Hn are mutually exclusive and exhaustive events with non-zero probabilities, and E is any other event with probability E which is greater than 0, then conditional probability of occurrence of H1, 1, 2, 3, n, where E has occurred, is given as in this way. That is probability Hi divided by E. I means 1, 2, 3 and so on. Probability H1 multiplied by probability E by H1 divided by probability H1 multiplied by probability E by H1 plus probability H2 multiplied by B E by H2 plus probability Hn into probability E by Hn. Now we will use this formula for this example. Suppose bag A contains 2 white and 3 red balls, and bag B contains 4 white and 5 red balls. One ball is drawn at random from one of the bags and is found to be red. Find the probability that it was drawn from bag A. Let H1 and H2 and E be the events defined as H1 is bag A is selected, H2 is bag B is selected, and E, a red ball, is drawn. Now here clearly H1 and H2 are mutually exclusive. So probability H1 is equal to half and probability E by H1 equals to 3 by 5. Probability H2 is equal to half and probability E by H2 is equal to 5 by 9. When we put it into the formula, it comes to this way. Here 1 by 2 into 3 by 5, which is probability E by H1, and probability H1 is half. So 1 by 2 multiplied by 3 by 5 plus 1 by 2 multiplied by 5 by 9. So we put the values of these and we find out the probability with the help of Bayes' theorem. So here we get 27 by 52. So this is the basic thing which we have to remember regarding the Bayes' theorem. So this is all about Bayes' theorem for today. Thank you.